Hey guys, so we are on inequality word problems now. Okay, so over the past couple of days, we've been solving linear inequalities and compound inequalities. Today, our learning target for 2B is that you should be able to construct linear inequalities given constraints and in the context of real-world applications. Okay, so we're going to start off here. We are going to represent each of the following as an algebraic inequality and solve it if it's possible. Okay, so here it says x is at most 30. Okay, so when you see the word at most, okay, that means the biggest number it could be is 30. So everything else has to be less than that. Okay, so this at most means less than or equal to 30. Right? Because the biggest number we could have is 30. Everything else has to be less than that. Okay? Okay, here we have the sum. Okay, so hopefully we know that sum means adding. Okay, so we know that we're going to be adding something here. Okay? And when we see the word at least, okay, that means that is the smallest amount possible. Right? So that means everything else has to be greater than or equal to. Okay. So the sum of 5x and 2x, right? So sum means add. So the sum of 5x and 2x is at least 14. Okay, so that means it has to be either equal to 14 or bigger, right? Because that's the smallest it could be. Okay. After that, you should be able to solve it. So 5x plus 2x is 7x. Okay. And this means 7 times x. So if I divide by 7, okay, I get x by itself, right? 7 divided by 7 is 1, so that's why it's 1x. Okay, and then 14 divided by 7 is 2. Okay, so that means x is greater than or equal to 2. Okay. So then here for C, it says the product. Okay, so hopefully you know that product is multiplication, right? So the product of x and y, so I am multiplying them. Okay. And then it tells us that it is less than or equal to. Okay. So I'm going to write less than or equal to, and it's less than or equal to 4. Okay. And then here we have 5 less than a number. Right? So if it's 5 less than this number, this means subtract. Okay? So this is a subtraction. Okay? It's under 20. So that means if my number is y and I want 5 less than that, I do y minus 5. And if it's under 20, that means it is less than 20. Okay? If I add 5 on both sides, I get y less than 25. Okay. Okay, so hopefully this was kind of an introduction to some of our key words here. Okay, now we're actually going to be talking about actual word problems. Okay. So here it says that the cost of a gallon of orange juice is $3.50. You have $15. What is the maximum number of containers you can buy for $15? Okay, so since my price here is $3.50, okay, and I want to find the number of containers, I'm going to set x equal to the number of containers of orange juice. Okay. And so if it's $3.50 for each of them, if I do $3.50 times x, that will give me the price, right? So if it was 1, then it'd be $3.50, right? If it's 2, it'd be $7, etc., right? And because I only have $15, the amount I have to spend has to be less than that or equal, okay? Right? You can't spend more than you have, or else you will go into debt, right? So that's why it has to be less than or equal to. The amount of money I spend on orange juice has to be less than or equal to the money I have. Okay. After that, all you have to do is solve. Okay. So just in case we were wondering where I got my numbers, 350 is here. Okay. And the $15 is what I have. Okay, so then I divide by 350. Okay. The reason why I'm still leaving the 0 here is because we're talking about money, right? And so normally money has 2 decimal places. Okay, so 350x divided by 350 is just x, right? Because this cancels out to be 1. Okay. And then 15 divided by 350 ends up being approximately 4.286. Right? But because you can't have 0.286 of an orange juice bottle, right? You can't go to the store and say, hey, can I have 0.286 of this, right? And you can't spend more than you have. That means the maximum number of orange juice containers you can buy is 4. Okay. So now let's go to the next one. Okay. Okay, so here it says which statement or which situation here is modeled by x plus 3 less than or equal to 12. Okay. So in A, it says Jenny sold 3 cookbooks. Okay. To earn a prize, she must sell at least 12. Okay, so if we make x the amount that Jenny still needs to sell, okay, and we already know she sold 3, this gives us how many she needs to sell, right? And we know that she needs to sell at least 12. Okay, so that means what she sells has to be greater than or equal to 12, right? So the 3 is what she already sold, okay? The x is how many more she still needs to, right? And that has to be greater than or equal to 12, right? Because she has to sell at least 12. Okay, that doesn't match, so it's not A. Okay, so let's look at B. Okay, so here Peter has 2 baseball hats. Peter and his brothers have fewer than 12. Okay, so if we put x as the amount of hats his brothers have, right, and we add 2, that's how many Peter has, we know that they have less, in total, they have less, fewer than 12. Okay. This doesn't match, so it's also not B. Okay. Then let's look at C. Okay, so Sam has 3 bottles of water, okay, and together Sam and Dave have at most 12. Okay. So if we make x the amount that Dave has, plus the 3 that Sam has, this is the total of what Sam and Dave have. Right? And since it's at most 12, that means it has to be either less than or equal to 12. That matches, so our answer here is C. Okay, and just for practice, let's look at D too. Okay, so here Kathy must swim 3 laps in the pool this week, right? She must swim more than 12 laps in a month, right? So if we have x, how many she has to swim, still has to swim, plus the 3 she already swam this week, we know it has to be more than, so greater than 12. Again, that one doesn't match, so it's not D. Okay. Let's move on to the next one. Okay, so Adrian works in New York City and makes $42 per hour. She works in an office and must get her suit dry cleaned every day for $75. If she wants to make more than $260 a day, at least how many hours must she work? Okay, so let's highlight some of the stuff we know. Okay, so we know she makes $42 per hour. Okay. We know that she needs to spend $75, right? So every day she needs to spend $75. Okay. We know that she also wants to make more than $260. Right? So that's a key word here, more than $260. Right? And then we want to find out at least how many hours must she work. Okay. So since I want to find out the number of hours, I'm going to set my variable x to the number of hours she needs to work. Right, the variable we choose doesn't matter, right? You could choose h if you want to match the hours. Okay, that's fine too. Okay, so let's talk about her amount of money. Okay, so if she makes $42 per hour, if we do 42 times x, this gives us the amount of money she makes, right? So if she worked 1 hour, that's 42 times 1, $42. If she worked 2 hours, 42 times 2, that's $84. Okay, so this is the amount of money she makes. She needs to spend $75 every day, right, to get it dry cleaned. So if she needs to spend that money, that means she's subtracting the amount of money she has. Okay, right? And if she wants to make more than 260, okay, so what she makes per hour minus what she needs to spend on dry cleaning has to be more than, so greater than, 260. Okay? Okay, so let me just highlight everything we got. Okay, so this, whenever you see per, it means time, right? So 42 per hour, that's why it's 42 times x. Okay. She has to spend 75, so that's why it's subtract 75. Okay. And then because it's more than 260, right, so we have this. Okay. So let's solve. So first I'm going to get rid of this minus 75 by adding 75. So we have 42x. Negative 75 plus 75 is 0, so plus 0. That's why it's just 42x. Okay, 260 plus 75 gives us 335. Okay, and then next I need to get rid of this 42, since it's 42 times x. Okay, I get rid of it by dividing by 42. Okay, so 42x divided by 42 is x. And then 335 divided by 42, that is approximately 7.976. Right? And so since she wants to make more than that, she needs to work more than 7.976 hours. So that means Adrian needs to work at least 8 hours. Because it has to be greater than 7.976, so that's at least 8 hours. Okay, then let's flip. Okay, so here Chris is celebrating his birthday at the fair with his friends. He wants to pre-order the fair tickets online. Each ticket costs $15, and there is a flat online service fee of $12. If he can spend no more than $100, can he invite 6 friends? Okay, so let's highlight some main information here. Okay, so I know that each ticket costs $15. Okay. I know that there is a flat online service fee of $12. Okay, so that's more money he has to spend. Okay. Right. And we know that he only has $100, right? So again, you cannot spend any more than you have, so no more than 100. Okay, so let's set this up. Okay. So let's make x the number of tickets, okay, that he can buy with $100. Okay. So if each ticket costs 15 times x will give me the amount of money spent on tickets. We also know that he has to pay a flat online service fee. Okay, so that's more money he has to spend. Okay, and since this is only paid once, right? It's not per ticket, it's not per person. Okay, that's why it's just plus 12 once. Okay. And again, since you can't spend more money than you have, okay, the amount that he spends has to be less than or equal to 100. Okay. It's here. Okay, so let's solve. So the first thing I'm going to do is subtract 12. Okay, I'll end up with 15x is less than or equal to 100 minus 12 is 88. Okay. Right, then I'm going to get rid of this 15 times x. I'm going to get rid of the multiplication by 15 by dividing by 15. Right? 15 divided by 15 is 1, so that's why it's 1x. Right? And then 88 divided by 15 is 5.866, and it repeats forever. Okay? So this means that Chris has to buy, if this is the number of tickets he has to buy has to be less than or equal to 5.866. Right? Again, you can't buy 0.866 tickets. So the most tickets he can buy is 5. Right? But if he invites 6 friends and himself, that's 7. Okay, so what this means is Chris cannot invite 6 friends. Okay, and the reason why is because he can only buy 5 tickets. And that's because of this. It has to be less than this. Okay, then let's move on to the next one. Okay, so Carla here is deciding whether or not she should become a member at the gym to use the basketball courts. Okay. The membership cost is $135. Members pay $2 to rent out the basketball courts. Non-members can rent the court also, but they have to pay $11 each time. Okay. How many times would Carla need to rent the court in order for it to be cheaper to be a member than a non-member? Okay. So again, let's highlight some important information. Okay. So we know membership cost is $135. Okay. We know that members pay $2 each time to rent a court. And if you're not a member, right, you have to pay $11 each time. Okay? So I'm going to define my variable. I'm going to use x, right? Since we want to know how many times Carla needs to rent, okay, x will be the number of times Carla rents the court. So there are 2 types of costs. One is membership cost, whatever members pay. The other cost is for non-members, right? And we're comparing them. We're seeing when is it cheaper to be a member. Okay, so on the left side, I'm going to put my membership cost. Okay, so it costs $135 for membership. And each time you want to rent the court, that costs $2. Okay, so plus 2 times x, the number of times you rent the court. Right? So if Carla rents it once, then it's $2, right? 2 times 1. If she rents it twice, then it's 2 times 2, $4, right? If she rents it 3 times, 2 times 3, $6. Okay? That's this. Okay? Right? And we're comparing it with a non-membership price. Okay? So if we want it to be cheaper to be a member, since this is our membership cost, we want less than. Okay? The non-membership cost, they don't have to pay a membership fee, right? Because they're not members, right? But instead, they end up paying $11 each time they want to rent the court. Okay, so that's 11 times they want to rent the court, right? So if Carla wants to rent it once and she's not a member, that's 11 times 1, $11, right? If she wants to rent it twice, that's 11 times 2, $22 if she isn't a member. Okay, so now let's solve it. Okay. So I'm going to move it to this side. I'm going to subtract 2x. Okay. So 135 I didn't touch. 2x minus 2x is 0x, so that's why it's no longer there. Okay, and then 11x minus 2x is 9, so 9x. Okay. Then I'm going to get rid of this multiply by 9 by dividing by 9. Okay. 135 divided by 9 is 15. 9 divided by 9 is 1, so 1x. Okay. Another way to say it, if 15 is less than x, x is greater than 15. Okay. And what this tells us is that if she wants the membership cost to be less than the non-membership cost, Carla needs to rent more than 15 times. Okay. So Carla needs to rent the court more than 15 times. If what? If she wants it to be cheaper to be a member. To be cheaper to be a member. Okay. Okay, let's move to the last ones then. Okay, so a store is offering a $3 mail-in rebate. Okay, for those of you who don't know what a rebate is, it's when you buy something and then you mail in something and you get the money back, right? So a store is offering a $30 mail-in rebate on all color printers. Okay. Lewis is looking at different color printers and they range from $175 to $260. Okay, how much can he expect to spend after the rebate? Okay, so if we know he's spending between $175 to $260, okay, I'm going to set it up like this. Right. Okay, so those are the prices he's looking at between. Okay. So if I make X the amount he's going to spend, right, so amount of money spent, okay, we know what he ends up spending will be a little bit less because of the mail-in rebate. So if we have X plus 30, right, what he gets back, right, and what he's going to spend, right, based on that. Okay, right, because if you think about it, when we're subtracting 30, he's getting those $30 back. Okay, so if I subtract 30 on each side, 175 minus 30 is 145. 30 minus 30 is 0, so that's why it's just x, right? Because x plus 0 is just x. And then 260 minus 30 is 230, right? So even though he's looking at printers from 175 to 260, because he's going to get back $30, if we subtract 30 from each, we get the amount he's actually going to spend, right? So Lewis can expect to spend $145 to $230 because he's getting those $30 back. Okay, and then here's our last one. We're going to write an inequality to represent the situation. We're going to graph the solution. Okay, so the recommended pH level for swimming pool water is between 7.2 and 7.6 inclusive, meaning it includes these numbers. Okay, we're going to make P the pH level of swimming pool water. Okay. So P, the pH, needs to be between 7.2 and 7.6. Okay. Right, so smaller number on the left, bigger number on the right, less than symbols. Okay. And then since it says inclusive, that's why there's the equal to. Right? And then if I were to graph it, 7.2, 7.6, close circle because it includes, right? And we want what's between it. Okay. And that's it for today. Okay, have a great day. Bye, guys.